Welcome back to Let Us Learn to Lead video series on free open source software designed by M. Srinivasan, Training Associate Mathematics, Kendra Vidyalaya Sangathan, Zonal Institute of Education and Training, Mumbai. Self-learning contents in video form on GeoGebra dynamic mathematics software is presented at this video series. To view the contents, you may join Google Classroom by using the class code 73AUMBO. In this video, you will learn designing a worksheet to visualize regular prisms. For preparing this video lecture, I used Windows 10 operating system, a licensed version, GeoGebra 5.0, a free open source software, and free open source screen recorder software. Let us start. Let me show you what type of worksheet we will be designing and show it to the children. We will tell them what is a prism and what is a regular prism, that is a base is a regular polygon. We are going to control the length of the side of a regular polygon also and the number of sides also. Now we will get the prism now by fixing the height. By changing the value of n, we will get different base, pentagon, hexagon, octagon, and so on. All are regular. And on the right side you are seeing the prism automatically coming, and you can fix the height also. Now after this we can ask the children to find the surface area and also the volume, and then check its value also by fixing it at 4, and then by 4 when they fix they know that it is in the form of a cube, therefore it is a regular prism which is a cube. Well, now let us try to design this dynamic worksheet from scratch. For that I have selected GeoGebra Classic 5 worksheet with geometry view, and in the option I have rounded off to 1 decimal place and labeling of new points only, and navigation bar is activated. Let us start with the heading regular prism. We can define what is a prism, and we can ask them that what do you mean by a regular prism. The child will come with the answer. If the base are in the shape of a regular polygon, then it is a regular prism. In the shape of a regular polygon, then it is a regular prism. Now what you can do, I already have told you, you can go to this text. Then if you want to put it in two lines, you have to simply press enter, and it will become at one below the other. Okay. Now regular polygon is easily available from GeoGebra, but if you want to control its side also, you can have a slider for its side for small a. Now you can have the from 1 to 10 with increment as 1. Okay. Is it okay now? Then you can have the number of sides, we can have a integer, therefore it will become n automatically. Regular polygon starts with 3 only, therefore 3 to 10 with increment as 1. Okay, both I am keeping it ready. Now let me go for this segment. Option is already I have taken as labeling of new points. Therefore I am going for this line segment with a given length. Let me touch it, it will immediately ask what length I want. I will type it as small a, which means that I am going to control the length of the side. Therefore, for example, I can move it. But I want to have different size of the polygon. Well, now once again, go to this regular polygon, touch this A, touch this B. It will ask what are the number of vertices. Now you give it as n. When you give it as n, what will happen? When I move this n, I will get equilateral triangle. 4, I will get a square. 5, I get a regular pentagon. 6, I get a regular hexagon, and so on. Is it okay now? Now you got. Okay, let us keep it over here. Now let us go for the height which we want for this prism. Therefore, for the slider, you can have it as HEIGHT, and in the minimum you can have it as 1. Height cannot be negative. We can have it as up to 10 with increment as 1. Okay, this height is also ready with me. Now I am going for this view. Go to this 3D graphics. Okay, it is moving. Okay, let us stop it. Okay, now let us stop it, and then okay, now I am getting its base now. The base can be moved, and then I can have it as AB, AB, AB. Anywhere I want, I can have it. Okay, I will just keep it AB here. Okay, it is ready. Now I will try to go for the prism now. For that, click this 3D graphics. 3D graphics toolbar will open. Go to this pyramid. Extrude to prism. I am going to extrude this polygon into a prism. Touch it. The color will change. It will ask you the altitude. My altitude is HEIGHT. You can have small h, capital H, whatever you want. But I have taken it as HEIGHT. Okay, when I move this, you see it is going on. Okay, now n is 4, n is 3, n is 4, n is 5, n is 6, n is 7, 8, octagon, and so on. Okay, fantastic. Okay, if you want to show the difference between the bases, what you can do is keep it at 4 or 3. Go for this is object property. Go to this color. Have a separate color for the base and have the opacity as 75. Come down. Again, go to the top. Little bit do like this. Go to the top. Okay, I'm just selecting the top. Again, right click object property. Same color you give. Same opacity as 75 points you give. Okay, now you can. Okay, now a child can understand that actually what is its the base and what are its sides. When I convert it into 5, you see 6, 7 and so on. Okay, now a child can understand that a regular polygon has how many bases, then what are its sides. The child can understand. Okay, now go for it, ABC text, and then I declare it. Now one thing which you can ask the children to do it is where is going on changing. At a particular spot, you can ask them that how many vertices are there, how many edges are there. You can ask them to note down. For example, you keep it as n is equal to 3, ask them to note down n is equal to 4, n is equal to 5 and so on. Okay, now as usual, it is very simple idea now. The surface area formula, area of the base, the surface area formula, come back, therefore ABC, therefore surface area formula. What are required for the surface area? Area of the base and perimeter are required. Okay, let me keep it as 4. Okay, I will go for this perimeter. Perimeter is actually very simple. It is n into a, therefore no need to worry about it. Okay, now we will go for the distance. It is n into a. It is 4 into 4. For example, if it is 5, it is 5 into 4, 6 into 4, 7 into 4, then 7 into 5, 7 into 8, okay, 7 into 6, then 7 into 7 and so on. Okay, it will be very easy for you to remember it also. Okay, now let us try to display them over here. Therefore, go to this ABC. Therefore, area of the base is equal to, for square it is very simple, but from the object it has been taken as a polygon. Therefore, poly 1. Therefore, you have to select poly 1. Let us check out where is that poly 1. Remember this, it will be at poly 1 because these are all polygon. They are not quadrilaterals. For 25, you see a is equal to 525, a is equal to 636, a is equal to 749, a is equal to 864 and so on. Therefore, I will keep it at 4. Well, now perimeter of the base, I think it is very simple. Go for this text. Go for this text. Perimeter of the base. Okay. Perimeter of the base is equal to in the object you see perimeter poly 1. Good. Perimeter poly 1. Therefore, when I am moving this into 5, it will become 20. 6, it will be 6 into 4, 7 into 4, 8 into 4, 9 into 4. Very simple. Perimeter of the base you got. Okay, now I think we can declare the height also over here. Therefore, height is equal to height from the object. I think HEIGHT. Where it is, you have to search it. Okay, here it is. Okay, height is equal to 4. Now go to this view. In that, take this input bar. Now you directly type capital S is equal to. Now I think we cannot have capital S. Therefore, we can have TSA is equal to, because S may be there when you go on increasing it, S will be there. Therefore, you have TSA is equal to 2 times I think poly 1. Okay, you remember it. Okay, plus then perimeter of the base, therefore perimeter poly 1, okay, perimeter poly 1, then multiplied by, because that is the variable HEA height, okay, enter. Okay, now from here I think I can write what is the surface area now. Surface area is equal to, I am not using capital S because S is already taken as one of the vertices, that we should be a bit careful. You have to search for TSA. It is TSA here. Okay, I got the surface area. Now go to the formula for volume. The volume formula is very simple, area of the base into height. For area of the base into height, or come back over here, go for this ABC. Volume is equal to area of the base into height. Volume is equal to area of the base into height. Okay, therefore capital V is equal to, what is the area of the base? It is poly 1. Okay, then multiplied by, then what is its height? It is HEI GHT, therefore height. Okay, that's all, very simple. Okay, come back over here and then you declare it volume is equal to, okay, VOLUME, volume is equal to, from the object you select capital. Oh, good. Oh, I got it now. Okay, now shall we check whether when n is equal to 4? Okay, it is 64, 4 cube. It is 64. For surface area also, you can check it out. Suppose if the base is a square, what will happen? If the base is a triangle, what will happen? Now, this is a very highly interesting, a dynamic worksheet where a child can understand what is a prism, what is a regular prism, what will happen if the regular prism is having an equilateral triangle as the base, square as the base, regular pentagon as the base, regular hexagon as the base, regular octagon as the base, and so on. And they can understand that when they change the height, what really happened to it, and they can calculate the surface area and volume at any spot. Not only that, they can visualize it by rotating it, how it looks like. It is having 2 regular polygon as the base and the remaining are all rectangular sides. Highly interesting worksheet. Thank you. Let us learn to lead.